Thank you all for coming. It's awesome to see such a big turnout and to know that so many people are interested in doing research. So my name is Seth Rubin. I'm a professor in chemistry and biochemistry. I'm also the current faculty undergraduate director. So I organized this along with Marla, who just walked out of the room. But Marla was the one telling you to sign in and get sick. There's Marla. Marla Hesselink is our awesome advisor in the department. If you're a BMB major, you might have worked with Rexton. He's the BMB advisor, Marla's the chemistry advisor. Together, they're our team that are in the department office and your go-to people for all advising questions about the major. We have a lot of other people helping us out today. Thank you so much. We have Peter Weiss. He's an instructor in chemistry, also with the Physical and Biological Sciences Division, and is spearheading a effort that's been going on for a few years to integrate work-study programs with doing research, and he's going to tell us about that in a little bit. We have 4 undergraduates, so current undergraduates. I think you're all BMB chemistry, maybe some MCD, but they're all doing research in chemistry and biochemistry department. So it's Vicky on the end, and then Sarah's a grad student. I'm back to her, Mel, and Michaela and Connor. Okay? And we'll hear from them all a little bit, and they're going to tell you about their experience, how they got involved in research, and why it's been meaningful for them. Sarah Levy is a PhD student in the department. So she volunteered to kind of give the perspective from a graduate student and the experience that she had as an undergrad. And she's just also awesome about everything, super engaged in undergraduate education, and so was willing to help us out. So we'll hear from her in just a couple of minutes. So feel free to interrupt with any questions you have along the way. We do have some designated time, hopefully about 50-20 minutes at the end, where you can ask questions, but feel free if anything, if you get any ideas, just interrupt us. So I thought I would just start giving you my opinions, idea about why one should get involved in research as an undergrad. And clearly you're all here, so something has piqued your interest, and that's great. But just to tell you from my perspective, and Sarah will give you a little bit from her perspective in a minute, why is doing undergraduate research important? And this is definitely all shaped by my own experience in my own career, where I started out as a pre-med, like many people who come to college, pre-professional, pre-health. And it was when I got involved in research that I realized that I really wanted to be a research scientist and become a professor. And number one thing I would say is it builds identity as a scientist. That we see this time and time again with students, and there's lots of research that's been done on this, that students who kind of sit in introductory science classes, chemistry, biology, and have all of this kind of information just blabbed at you, it's really hard to identify as a scientist in that setting. It's really when you're engaged in doing research and thinking about scientific questions that haven't been answered yet, thinking about how one formulates and tests a hypothesis, the scientific method, that until you're doing that, that's when you really start to identify as a scientist and become motivated as a scientist. So it's about building identity of what it really means to be a scientist. Like I just described, a lot of people don't find direction in terms of what they want to do with their undergraduate degree and what career they might have until you start doing research and learn you love it, and hopefully you'll learn that you love it. Yeah, and the other really important thing is it actually helps you learn better in your undergraduate science classes. And this kind of is what the lab classes do, right? I mean, experimental science is a hands-on thing, and you can hear about the concepts, but it's also important to be engaging in them in the laboratory, because this is all experimental science. So as you do that, it actually helps you to understand the concepts better. And I've seen countless times students struggling in undergraduate classes until they start doing research in a lab. And then just everything starts to click for them. They get more motivated, but also the concepts start to make more sense when you actually are practicing them as a real scientist. So that's an added benefit. Developing a community, like our undergraduate students here, they'll probably tell you that is when they started working in a lab that they really connected with the department as a department, and all of the graduate students and other undergrads in the major and the faculty. There really is a community here that's kind of hard to access when you're just showing up for lecture. But when you're coming and you're working in a lab and meeting people in the hallways and going to department events, that's when you really kind of build a community that becomes really supportive as you get into your later years of college. And that also can be quite motivating. Along those lines, more interactions with faculty. As you've all probably experienced, it's kind of hard to talk to faculty when you're one of 450 people in an intro chemistry or biology class, or even when you get to the upper div chemistry and biology classes, it's still 100 people. And so you might go to office hours and talk to some faculty, but being in a laboratory really gives you much more opportunity to engage with faculty, and they become more of a mentor to you. And it's the opportunity to learn more from them, get mentorship, and then, of course, as you go to apply to graduate school, professional school, or jobs later on, building that relationship makes for a much stronger letter of recommendation as well. And then finally, writing a senior thesis or presenting a poster, going to a conference. These are all things, again, that kind of build identity as a scientist. Writing about the research that you did, you can always take this for credit and get a grade. It also can lead to department honors. So there's lots of good things about doing a senior thesis that you'll have the opportunity to do if you get into a lab, especially early on. And then presenting a poster at a conference is another way to really get motivated about science and start to identify as a scientist. So those are kind of my thoughts. Oh, get name on a paper too. Yeah, that's always good for your CV. And we've had lots of undergrads publish. So that was my perspective. I'll turn it over to Sarah. So she might have a few things to add to that, but also I asked Sarah to focus on, okay, now that you all know you want to do research, how do you go about doing it? So what are the steps one would take to find a lab and ask to join a lab? So thanks, Sarah, again for coming. I'll turn it over to you.
So I think Seth did like a really awesome job with like clap for Seth a little.
A really awesome job of like explaining why research is important and why it's like exciting and fun to do, and you get to feel like a Harry Potter like potions master if you're doing chemistry, or you get to feel like very cool and like cutting edge if you're doing biology or chemical biology at the school. So it's really fun as well as being like academically beneficial to you. But definitely a lot of us feel super funky of like how to get into research experiences, and also kind of like when we're there, how do we feel comfortable? So it's a weird thing, but I'm asking you to take out your phones and scan this document. So basically what this is, it's like a living Google folder. So it'll constantly be updated with materials on different funding opportunities, how to get letters of rec, kind of like guiding documents to how to walk you through research opportunities. And I've had the pleasure of doing this kind of like walkthrough of all these materials with a number of students at the school. And it's been really fun and engaging, not only for myself as a grad student, but also I think for the undergrads as well. Just kind of like watching them get to that finish line has been really fun and exciting. And I'll bring it back up at the end. So if you didn't get it, it's totally chill. And also this entire presentation will be in that folder. So it has a lot of text.
You can email Marla too.
Yeah, you can totally. Sick. Heck yeah. So Seth did a really good job of highlighting why it's important and kind of like the way that we make ourselves feel like a scientist. And I kind of wanted to bring in some of the robust science data for that. So Science did a study of how early research, active learning, and learning communities contribute to both identifying as a scientist and learning science. Because as you identify as a scientist, you build a little bit of that confidence and like excitement to kind of take things on your own in the lab. And that translates to motivation to keep driving your projects forward and kind of building a tool set to evaluate the scientific problems that you think are important. And I think like something that's really core to this experience is that we feel like it's really important to feel like your thoughts and ideas matter, and that you have a tool set to address problems that you see in the world. And I think science bridges us towards that by giving us like a setting to build those tools. And then also giving us kind of a format to think, okay, like I know how scientific experiments are structured. This is how I can apply it to my problem that I see as important. So I really think, yeah, if you're gonna like think about science and kind of like the how you get here and how you like become a PhD scientist, it's totally through finding that motivation early on and getting like really excited and just finding the thing you love. And that thing changes a lot, because definitely started as a synthetic chemist and now I am an analytical chemist. So it changes brands, but the passion definitely like should, find that early and it persists. So a lot of this is going to be actually going through the deliverables of like, how do you research what lab you want to find? Because going through the department website is really intimidating, and specifically going through the different labs websites are really intimidating because there's a lot of information to parse through, and there's only a few things you actually need to focus on to be able to get as much information as you need to start like moving forward with the research opportunities. So you want to figure out what type of work is available and the work you want to do. Because the work that you, like your dream project might not be the first project that you work on, but every project that you do work on builds that tool set and builds the box a little bit bigger so that you can get to your dream project. And we've all kind of been through this, like, I think any of us here who did an undergraduate opportunity, like maybe it wasn't exactly in what you wanted to do, but you learned cool stuff. And so I'm really going to focus on going through the research and publications, because I think that's where, like, at least myself and definitely even like other graduate student and postdoc peers have said, like, literature is the most intimidating part of getting into science. You guys have all seen it, like these publications like are listed just with like weird names and DOIs and stuff. And then you get to them and they're super chunky. So big research papers, fun and cool, kind of heavy. Some labs will have this little research section in there. So it's usually more like digestible material. So you can look at like videos, look at brief summaries of the research. So that's where I'd say like start there and then go to the publications. But if we focus on just the publications, we kind of want to think about one thing, right? Because like science papers all look like this. They're super long. The abstract's gnarly. The figures don't make sense. They have like weird plots. And there's like a million pages of SI. And so to put all of that down, just look at the abstract. So I think to go into a meeting with a graduate student or a PI of a project you might be interested in, you don't need to focus on all the heavy stuff. You do need to focus on understanding what they're doing. So look at the abstract and try to decode what the problem is, the description of the research method or like how they did their experiments, what they found out, and then like what they thought about what they found out or their conclusions. So I just want to like explicitly say this because science is like intentionally very gatekeeping with the jargon. And it's super gnarly to parse through the jargon. So I Google everything, like still as a graduate student, I Google anything that I don't understand and I like write it in the margins so that when I'm reading, I have like a comprehensive overview of what I'm actually looking at instead of like looking at the perturbed pathways and the like different biocatalyst enzymes. Like I want to know what I'm actually like looking at in real people words. So that is something I just want to like explicitly say is totally like encouraged to do. And then there's going to be techniques that you learn that are unfamiliar, and that's okay. You're going to learn them like on the job. You're going to learn them by asking questions. And we all start by saying we don't know internally and like freaking out internally. So that's like how everybody starts. And so when you're going through these research opportunities, it's really good to have a tracking document because you're applying to a bunch of different labs and you want to keep all the information in one place and kind of like keep yourself not necessarily like accountable, but like persisting through the opportunities. Like it's everything that every time you reach out to a professor, that's a milestone, but it takes a lot of work to get there. And so every single time you want to make sure you're tracking and getting advice. So like having people edit, and then kind of making sure you're getting to the finish line, which with each of your deliverables, and I'm going to talk about what those are, but you can find a student tracking document in that folder. Another document that I have to track and kind of take more in-depth notes about your progress is this overview document, and all of this is in that link that you guys scanned in the beginning. And so it walks you through not only how to note take for your labs of interest, but a lot of the things you'll need, like how to write for like outreach to a professor for a letter of rec, or how to like reach out to your PI. And so these deliverables look like writing a statement of interest. So this can be like why you're excited about science, what brought you here, how your journey's been so far, what you want to do in the future in like your dream world. You want to write and ask for letters of rec just to have them in your back pocket for when you are applying for research opportunities. They really strengthen kind of like having someone to back up your work, or just like who you are as a person really strengthens kind of like argument for like, I should be in your lab because I'm really cool and fun and good at science. And then it guides you through drafting an email to a professor and how to write an academic CV. Because I think a lot of us have resumes, but writing an academic CV is like a whole different fun thing. And I know I'm blasting through this really quick, but you're going to have all these materials access to you later. So to get to the finish line, you do want to If you're able to practice your interview, so reach out to a graduate student or peer. And I have a bunch of like practice interviewing questions here, but you can have somebody basically like hold a mock interview with you, or there's videos on YouTube where this guy like nods and says, as he asks you questions. So if you Google like interviewing questions for a lab, it's a good thing. I did it a million times before my graduate school interviews. Super weird. And then this bottom part that got cut off says following through the next steps. So your funding applications, which I think are going to be talked about later, are going to have to be repeated each year unless they're reawarded. And you do want to, when you meet with graduate students or in the lab, you want to talk about the lab dynamics, the expectations for communication with the PI, and then just like you want to communicate and advocate for yourself as far as balancing your school schedule, which is really demanding, with your lab responsibilities. Interviewing is fun, but also makes you want to pee your pants. So yeah, so just to kind of like wrap it up and walk through all of it. So the way to start this is really to have a one-on-one discussion with your TA, a mentor, or a faculty member about research interests. And TAs are really your bridge to this. Like your TAs have smaller class sizes, they have more opportunities to talk with you, they have office hours. So this is where you like push it and you're like, I want to do research, what's out there for me? And that's like, I encourage that. Go pounce on your TAs. Then you want to work to complete your deliverables. So like get that CV going, get your statement of interest started. As you work through them, you want to kind of like find someone to feedback them with. So usually that would be your TA, or if you could find an external mentor in the department, you want to get kind of feedback and see how, like what should be edited, and then email outreach to your PI and get interview. And then every single time you do that, celebrate yourself, because you might have to do it a bunch of times. There's like a whole lot of undergrads looking for opportunities. And so celebrate every single time that you go through the process and like eat a cool lunch and take a nap. And then once you're in the lab, I think this is really important to remind people, but undergrad research should not be grunt work. You should not be like asked to do the same exact thing every day repetitively. Like you're not engaged in learning in that. You should be developing new skill sets, be able to contribute your own ideas, get supported in new techniques that you want to learn, and just really feel like if somebody asks you what your project is about, you should feel comfortable explaining the background and the biology, and you should have support to get to that point. It's okay to feel like you don't know anything in the beginning. I was talking with my roommate about this last night, and we were both very clear that like, even now we feel like we don't know anything. So that's like a completely normal feeling. And that feeling sometimes goes away and sometimes comes back, but it's like 100% normal. And when you do feel that way, just advocate for more support and oversight. And you might feel like you're being pushy, but you're not. You're advocating for your needs and what's going to benefit you, and your work benefits whatever graduate student you work for and the PI that you work for. So you are bringing value, and you can advocate for what brings value back to you. So that's kind of all I wanted to say. And I wouldn't be able to be in graduate school without having really sick mentorship. So this is like another reason why it's really important to find cool mentors, and the incredible students that I've been able to teach before. But I really want to highlight the work of Dr. Allegra Iroy-Ravelas. I want to highlight Dr. Catherine McCarthy, and I want to highlight Dr. Laura Sanchez, who are all really, really incredible role models to me, not only in support, but in building my own tool set and carrying out the scientific problems that I see as important. And Kyrie, who is an amazing little scientist. And you can take my email down if you ever need anything. I am here. I hold office hours for students. Yeah, and here's that thing again if you guys need to scan it. But that's all I have to say.
We'll have time to at the end for sure, and some of the undergrads I think we'll get into more detail about kind of each of those steps of the process of finding a lab that you're interested in and reaching out to that professor and inquiring. That is not where we are. Oh, I wanted to go to here. Okay, let me just spend a couple minutes talking about funding opportunities. So usually at first, it's common to do research as a volunteer, to not get paid for it. But ultimately, as you get going and as you get experience and as your CV is more competitive, there are funding opportunities out there. And it's important to think about doing that for a number of reasons that are listed here. I mean, it's fine to always just volunteer, but it really does free up time that you can dedicate to research. So, like for example, if you have a part-time job that you're using to support yourself, oftentimes instead of doing that part-time job, you can do the research and get paid, and that gives you even more time in the lab. And Peter's going to talk about this work study initiative that I mentioned that really tried to integrate that. You can use fellowship money that you get to purchase needed reagents or equipment. Oftentimes, most of the time, the lab where you go and work, there'll be grant money that that lab has to do this, but it always helps and it kind of empowers you if there's something that you feel like you need to test an idea that you have, and your fellowship actually provides you with money to buy a reagent. And then I already mentioned how great attending conferences is. Oftentimes, fellowships have money to support your travel to a conference, like paying your airfare to go to France or an international meeting. That sounds like an amazing thing, right? So there are fellowships that do that. So you should be thinking about that. So so here's just kind of a smattering of funding opportunities that I'm aware of and been thinking about like lately. And there's also there's links at the end of this in one of the slides that will take you to web pages that kind of have all this information and list fellowship opportunities. One that's a pretty easy one that you can do even really before you get into a lab is this. There's 2 awards and I think they alternate years. So one's called the PBSci Undergraduate Research in Science and Technology Award, and the other is called the Correct Scholars Award. And the applications are due in late fall. I think the deadline is like Friday, so it might be a little bit too late for you this year, but keep it in mind for next year. And so all you need is a faculty sponsor. So you could do this even before you're in a lab, but you're at the point where you're engaged with a faculty about potentially joining their lab, but you have an idea of what the research is that you'd like to be doing. You write a really short proposal about what that research would be, who the mentor would be, and what you would spend the money on, and submit that. And these are, but it's really short, like 500 words on the proposal, and the awards are like 2,500 to 3,500. So that's just a nice way to get you started, thinking about what you're going to do, engaging with a potential faculty mentor and discussing a project, all building towards applying and getting one of these awards. Whoops, wrong way. Okay. Probably the most money on campus to support undergraduate research is through the STEM diversity programs. So I highly recommend you go check out that website, stemdiv.ucsc.edu. Is anyone familiar with STEM diversity programs also? Nobody. Okay, good. Yes, definitely check this out. So there are a number of grants that faculty and staff at the university have applied for from agencies like the National Science Foundation, the National Institutes of Health, and they support undergraduate research. A lot of it, most of it is geared towards diversifying the scientific workforce, diversifying the undergrads who participate in research. So it leans towards supporting people from underrepresented groups. What that means, how broad that is, whether or not you qualify, definitely reach out to that office and inquire about it. But there's some pretty incredible programs like MARC, which is actually a program that I'm the faculty director of. You just raise your hand.
No, because I'm a partner.
Awesome. I thought I saw the raised hand in the format. That's an incredible program. It will pay you a stipend and pay your tuition and fees and create this community of MARC scholars where you're all taking classes and doing research and taking workshops about finding careers in science and applying to graduate school. So yeah, maybe you can talk a little bit more about that, your experience with that when you go in a minute. But so there's lots of programs like this that you should be aware of. The applications for those are all usually around like January, February, if I remember right. So like kind of like winter. And you basically apply in the winter and it would start that summer. They also pay for you to be on campus during the summer as well. So these are really great programs. I highly recommend you check that out. Okay. As I mentioned, lots of the labs on campus in the sciences are funded with grants. Oftentimes in those grant budgets, there is money to support undergraduate researchers. You should definitely, once you get into a lab, ask your PI, your professor, about that. As I mentioned, usually you'll be asked to volunteer at first. But then lots of professors will, especially over the summer, pay for students to work in the lab. So I really try as hard as I can over the summer to pay undergraduate students to be in the lab, because then you can dedicate 40 hours a week during the summer to research, and that's when you can really be engaged and accomplish a lot. So definitely understand that that's something that can be done. Peter's going to tell us about the Work Study Research Initiative in a minute. There are a number of other awards that you should be aware of that you apply for kind of at the end. The team award, the Needs and Chances award that you do a thesis, but I call these graduation awards. So maybe not on your immediate radar, but just start to learn about them, because they can offer financial support as you kind of move forward and graduate. And then there's also, and there's lists on the university websites about this, external opportunities, national organizations that want to support undergraduate research. Barry Goldwater Scholarship is just one example. They tend to be pretty competitive, so just be aware of that, because they're national and kind of have to have super good grades. But yeah, try and find some and apply. And a lot of them, like Goldwater, also pays part of your tuition. So they're definitely good to be aware of as well. So here's the list of the websites. So you could take a picture, or you can get the presentation or ask Marla. There's a department undergraduate research page. There's kind of like a division list of funding opportunities that you should check out for sure. And one other thing that I can mention is there are also opportunities to get internships in industry. So there are a number of companies actually in Santa Cruz that do chemical and biotechnology research. A lot of them are kind of localized down by Delaware. A lot of them are spin-off companies from ideas that were started at the university. And Natural Products is an example of that. There are two graduate students in Scott Loki's lab, started this company a couple of years ago. They're down in Delaware. They always take like 1 or 2 interns a year. So it's definitely possible to find companies and inquire not only in Santa Cruz, but then there's also like a bunch over in San Jose or Scotts Valley. So I just put up a list there. But you could just, do a Google search for biotechnology companies, find some contact there, reach out to somebody and say, hey, are you looking for any interns? I'm interested in doing research, just like you would approach a professor. So learn about what the company's doing, say why you're interested. Okay, I think that is it for funding, and that brings us to Peter. We'll talk about the work study.
All right. Hi, everyone. I'm Peter Weiss. The past couple of years, I've been working on the Science Division Committee on Diversity, Equity, and Inclusion. And I'm also a researcher here, and I've put to work a lot of undergraduates in my lab, and just always really observed how great of an experience that was for the undergraduates, and also how much they have contributed to my research, and got my names on papers and gone on to bigger and brighter things. So one of the things I wanted to do on the committee was to enhance opportunities for undergraduate research, and generally and specifically what we want to do is try to make it more equitable for those students who have financial need. So a common scenario could be that you really want to do research in a lab, but because of your financial situation, you have to have a part-time job in order to support yourself. Or let's say you have a work study job, and so in those times when you're not taking classes and studying, you have to work, in the mailroom or something like that. And so what we wanted to do was try to encourage faculty to offer more paid research positions that would be available to work study students. And so we launched the it should be WSRI. I misspelled it, so sorry. And there's a lot of words on there, and we have another QR code. So if you want to take a picture of that as well, that's going to take you to a survey. And this is a way of just compiling information from students. It's going to ask you several questions about yourself, why you want to do research, what your strengths are. Do you have a work study award? If you're not familiar with work study, it's a federal program that, when you do fill out your FAFSA for federal financial aid, you'll often get that as part of as your package. Okay, and for a lot of students, sometimes it goes unspent because you need to get a job, right? It's work study. And so some students don't take advantage of it. And so we really feel like if there were more opportunities to work in a lab to actually utilize your work study award, it would be used a lot more. So students are one half of the equation, faculty the other half of the equation, because they have to create the positions and act as mentors, or have their graduate students and postdocs act as the mentors to the undergraduates. So in the WSRI, we're trying to coordinate all that. And the first step is to collect information on students who are interested in doing research. You don't necessarily have to have a work study award. You can fill out our form. And part of what we're going to do is compile all this information and deliver it to the faculty members to say, look, there's these available students who are looking to get research positions. And now you have, the faculty have a list that they can look through and see if there's a good fit. And then they can recruit that person or that set of people, or they can tailor a job posting to the kind of skills that undergraduates already have. So just trying to build some momentum to get more positions offered. For those students who get a research job and use their work study award, they become part of the WSRI cohort, and they will be eligible to join the RAD program, which is through the STEM diversity office. And this is like a professional development program where you get to learn some of the things that was already mentioned, like applying to graduate school and working on your CV and all sorts of mentoring that's available through that. Okay. Last point I just want to emphasize is the WSRI does not fund student research. Those funds come from grants to the faculty and or federal and state work study programs for students who meet those requirements. All we're trying to do is say, we've got students who want to work and they have work study awards, and we've got faculty who could benefit from those workers. Let's do, kind of that interpersonal connection to try to get those people to recognize each other and make a connection like that. And one of the benefits for the faculty is that the federal work study pays up to 50% of the student wage. So it's a really good deal for the faculty if they can get a work study worker. And more exciting news is that starting in January, there's going to be a new program. It's called the LAEP. I forgot exactly what it stands for, but it's through the Office of Career Success. And this is a state program. The eligibility requirements are going to be really similar to federal work study, but the benefit is that it's going to pay 100% of student wage. We got something like $9 million across the UCs with the express purpose of spending that money to fund undergraduate research positions for students with financial need. So another good reason to fill out our survey. We'll have your information. We'll keep you informed about all these different opportunities that are coming down the pipe. And that's all I wanted to say. So I'll take questions later or now if anyone has one. Keep it moving. Thank you.
All right, good. So we still have a lot of time to now hear from your peers and then hear from you your questions. So do you have an order? Start. So I asked each of the undergrads to just take 3 to 5 minutes and say some things about their own experience.
Do I start? Okay.
Go on.
Yeah, I'll start. Hi, my name is Vicky Villalba. I go by she, her pronouns. I'm on my 5th year here as a yes here, the dance minor. So sprinkling a little fun. Can't be just all science. But I'm in the Johnstone lab, which is a medicinal bio and organic lab, and I work with the Kayla and antimony. But yeah, so basically, I am a part of Sun Diversity, as I kind of like mentioned earlier, and I was in the position where I am like disadvantaged. I'm a first generation Mexican American, didn't know shit, didn't know anyone I could go to ask questions to know what it was about. So when I heard STEM diversity, I was really hoping that I got accepted, because like that would be my community. You know what I mean? Like a place where I could go in, just like not knowing anything, and they would give me all the information I needed. Especially coming into an environment that is very different from where I was from. I did experience this culture shock, and then this whole wave of imposter syndrome that just like hit me of like, oh dang, I don't think I can do science. I don't think I could be in science. You don't see anyone that does like really represent you and your background. So when I joined that program, it really helped me out. Like it told me what to do, what to say, you know what I mean, how to be more professional. So basically I just, through them, I was unable to not work because I did also have to work. I worked at the dining hall, and I also worked as a chemistry tutor. But I then just started like cold emailing professors, be like, hey, I saw your webpage and your stuff was really cool. You know, like a nicer version of that, but basically, and then Timothy Johnstone, my PI, he got back to me. He's such an amazing guy. Like, shout out to Tim. I love him. He's so kind. He's amazing. And when I met with him, I was really, really like nervous, and I went in like so professional. Like, yeah, we killed it. Like, oh yes. And then as soon as I went in, like he was so casual with me, even like used a little couple cuss words, and I was like, oh, okay, like we're chill here, okay. So like it kind of broke this barrier of me thinking that every professor is so like posh and so like, oh, science. I don't know, like that's just this stigma I had in my mind. And yeah, like Tim immediately was like, come on down and like join the lab. And I did. And I just want to say it's okay to not know anything. It's okay to not feel like you are this superstar student that has all the straight A's, because I can tell you I don't. I'm okay to admit that. But I still am here. I'm still gonna try to like get the experience that I'm getting. Like now I'm having a senior thesis, which is why I stayed a 5th year. And I would say that I would never imagine myself here if I told my high school self. So I just want to say, like, don't let anything discourage you, because there is a place for you somewhere. And if not, make that space. You know what I mean? Like, that's what we're here for, to push forward, to change what we see now. So, yeah.
Hey everyone, I'm Mel, they them pronouns. I'm a biochemistry major and politics minor, and I work in the Chemistry lab. We work with natural products, and I'm currently working with some fungi and some CV enzymes. We're trying to understand their biosynthetic pathways and all that good stuff. So that's been really cool. I'm also part of STEM Diversity. I'm under UC Leads. So it's a 2-year commitment, and basically work in a lab here. You get access to a bunch of different workshops, book clubs, different kind of events to basically meet other like-minded folks. And you also have an opportunity to go to a different UC. So you can work here for the summer for 1 year, and then you can go to a different UC the next year. So it's nice to get a different perspective of the different labs. Yeah, it's been a lovely experience. And in the beginning, similar to what you were saying, like I didn't know anything. I had like over 2 years of the pandemic, not being able to go into the lab. And as a biochemistry major, that's like the thing that you're looking for, is like hands-on experience and just like connecting with people. So it was a bit intimidating at first with like reading all of these scientific papers and not understanding what is going on in any of this. And then trying to sit down with my PI and say the things that I understand in the paper in a way that makes sense. So it's definitely intimidating, but the people here are so kind, and they're super patient and understanding, and I have awesome mentors, and it makes it super, super easy. And yeah, learning all the techniques in lab is also very fun.
Hi, I'm Michaela Gonzaga. I go by they them pronouns. I'm also in the Johnstone lab. That's who it is. Like Vicky said, it is a medicinal bioinorganic lab. Though I'm more so doing a more organic synthetic route, just because the graduate student that I'm under, we're currently working on carbon monoxide poisoning antidote, and so we're like, we finally made the antidote, and so we're hoping to get into like in vivo trials pretty soon. I took a pretty less traditional route than I think the other 2 people that I was spoken have taken. I just started over the summer as an undergraduate researcher, and first and foremost, before I go into that, I just want to tell you that the anxiety is real. Like, listening to this, I'm already in a lab, and it's already making me feel whew. And so I just want to let you guys know that like there is a huge barrier that like everyone here in this room, whether you are or aren't in the lab, is experiencing. And so how I kind of started was, I didn't know anything about this to begin with, but in my class last spring in Chem 110, which is intermediate organic chemistry, I was getting I was in the lab, there was the person who worked in the stock room eventually ended up helping out in the lab itself, and and Robbie Jenkins, yes, who is now in the Johnstone lab as a rotating graduate student, but he was always around, and I've always wanted to work in the stock room since my freshman year, and that dream kind of got cut short because of the whole pandemic and just not knowing who to go to for that. But when I did realize that I was talking to the stockroom guy, like, I was like, hey, and I started getting into it. Unfortunately, there weren't any positions available, but just expressing my interest of wanting to work hands-on in the labs and in the lab environment, that kind of sparks the, just like the attention, you know, like, and so when he saw that I was really, really, really wanting to get into this, at the end of the school year, like literally the last lecture, he was like, hey, what are you doing over summer? I was like, I'm taking classes, I'm around in Santa Cruz. He's like, you should join this lab. And so from then on, I went and sat in on one of the lab group meetings, which the labs here do, like a group meeting every week. I sat in that and I got to, like, you know, build a relationship with the PI and the grad student that he was going to recommend for me to work under. And so from that, I just ended up joining the lab over summer. I've been there ever since. Currently working as a volunteer, but hoping to get a personal project soon. I am a fourth year, planning to graduate this year, so I am sort of a late bloomer in that sense of, like, you know, but ultimately I'm so appreciative because, like the other two people were saying, I didn't know if I had a place in science, you know, and so being there and feeling accepted and like not reprimanded for not knowing things. Like, it's not a grade that's marked down. It's seen as an opportunity to learn, an opportunity to teach the next generation of scientists. And that's really what's important and what they try to focus on in the labs here. And so if anything, just take this as a work hard in your labs and people are going to recognize you and acknowledge you. Like, the teaching labs are there for a reason, and it's to teach the next generation of scientists and to really get us ready for whatever we want to do in the future. So, yeah.
Hey y'all, I'm Cam, he, him. I'm a fourth year chemistry major. I don't have a minor. I didn't know that was going to be a thing. So basically, I have been in the Oliver lab for coming on 3 years now. So it's been a minute. It's a materials lab that focuses on environmental applications of those materials. So still pretty in the inorganic category. And then my plan is kind of just to throw out like a bunch of experiences that I've had. And then if you have questions, you can ask about them a little bit further. But basically, yeah, so to get into the lab, I kind of just established like a good relationship with Scott Oliver through office hours during his classes. Not to take anything away from Sarah's presentation, but then one day I kind of just sent him an email and asked if maybe I could join, and he said, sure. So like, don't freak yourself out about the process of joining. It's okay if they say no, but it's worthwhile reaching out. And if they say no, it's nothing personal. Of course, here I am saying that I got really lucky. But yeah, so let's move on from there. So I started working under a mentor, and then I moved on to start my own independent project, maybe the summer of last year. So I am working on a project to mitigate chromate pollution from water using some of the materials that we study. I got this project funded through the Cord Scholarship. I also got it funded through the Undergraduate Research in Science and Technology grant, and then also got a couple of academic scholarships. And so all of that combined, I crunched some numbers the other day, and I think I've actually paid for my cost of living and my education here in Santa Cruz. So yeah, one of the things I was really concerned about with research was just the financials of it. So that was really exciting that, like, hey, there is that chance to actually work in a research lab and be able to pay for your living. There's a better way to say that. And then other funding opportunities that I've had, the NSF REU, which is the Research Experience for Undergrads, I believe is the acronym. So I did that over last summer, and then also TAing on campus, which is just a really good experience. And if you've been in the lab, I think it's easier to sort of reach out and get into a TA position. Anyway, so this independent project, it actually got me to write my own paper for inorganic chemistry. That is currently in the revision stage, so fingers crossed on that one. And then now, once that paper is finished, I am actually starting a project in the Johnstone lab, staying in the inorganic side of things, but just looking to sort of expand my experience and expand my knowledge. And then also I'm looking forward to grad school, and I can definitely say that like this research experience has been hugely beneficial when looking for grad school, not just in the sense of building an application and building a resume, which of course it has, but also in the sense of like, do I want to do research? There's a very valid thing where some people really love chemistry, but they don't want to do research, and that's okay. And you'll get that experience by being in a research lab. But also questions like, what do I want to research? When you apply to grad school and you apply to a lab, they're going to expect you to have some sort of an interest in something. And chemistry is this huge, massive field. So it's nice to, even if you join a lab or maybe that research isn't your dream goal, like Sarah was saying, you'll get like an experience of research. You'll get an understanding of how to actually pursue your own research goals. And then, yeah, if I could give really any advice, just so I'm not here just talking about myself, ask for things, apply for things. Even if you feel like maybe you aren't qualified, sometimes you get lucky, sometimes you have imposter syndrome and you're totally qualified, probably most of the time. So just all of these like grants or awards, like did not think I was going to get them, but I just put forth my best application, got really lucky a lot of times. And then the other thing is that, yeah, reaching out to professors can be super intimidating. Ask to go to group meetings. That's another way that I think is really cool to like get a feel for what the lab is doing and also the lab dynamics, and also showing that, hey, like I'm a dedicated person that would be a good fit for this lab. Oh yeah, group meetings. Group meetings are like labs will tend to have weekly, some labs have bi-weekly meetings where they'll tend to talk about their projects. So like each lab will tend to have a couple of different projects going on at once. For each grad students will tell the other grad students about their projects. So then that's a great chance for you to also hear about their projects. They'll also just do like general chalk talks, talking about general chemistry concepts or recent literature. And I can't think of a lab on campus that wouldn't let you sit in on a group meeting if you're interested. And that could be a nice way to break the ice. So emailing out to professors about that can be a good start. But yeah, I threw a bunch of stuff out there. If there are any questions, I think we're reaching that point.
Yeah, sweet. I think we're cool to see like a bunch of varied experiences, especially in terms of how they what they're doing. So yeah, we have like, I don't know, 12-ish minutes. And now we'd love to hear from you what your questions are, what you want us to go into more detail about. Yeah.
So I don't know, this feels a little bit silly, but I tend to keep some pretty weird hours. Do labs have like a time where they're closed, or are they open all the
I know from like certain experiences, if you're like not so thoroughly trained, the PI or the graduate students won't feel as comfortable like even if you're alone in the lab. I do think though that like the further that you go into training, more comfortable, they feel more confident in you, and you also feel more confident within your own like skill set, possibly. Because I know, but it's kind of weird because then the building closes at 5. So I think we can get keys, but that also depends if your PI accepts it or not. So it's very dependent on the lab.
And one thing I'll add too is like, I think legally, we're not supposed to have graduate students working, like just work without supervision, because like chemistry is dangerous, even though it's super sick and fun. So maybe find a graduate student that also keeps really weird hours, and then like you have somebody to like work with you in the lab, because there's just the danger of like a noxious fume is not contained in the hood, and then you pass out and then nobody's there. So that's a scary scenario. Sorry about that. But yeah.
I think that's right. I think it is department policy. Graduates can have keys, but it's left up to the individual professors whether they're on board with that. Safety, right, is an important thing. So definitely when you're starting out, I mean, nobody, not even the graduate students, should really be working in lab by themselves because there's safety issues there. And definitely at first when you're training, it's nobody gets thrown in the lab and told, go do something, right? You're always like paired up with somebody to train under, and so yeah, you need to have a compatible schedule, but it does become more flexible. Yeah.
So I was wondering, I know that you say like there's definitely steps before you're reaching out to professors directly, but when you get to the point where you are reaching out to labs, two things: are you reaching out to a lab manager, the person who runs the lab completely? Are you just supposed to go through a grad student if you like had already formed a relationship with them and wanted to work in their lab on a larger scale? What does that kind of look like?
So I think that there are a lot of different routes that you can take to get into a lab. There's not really one answer to this. If you're going to reach out to the lab, sort of just like a cold email, probably the PI, principal investigator, which is to say the professor who leads the lab, which is to say whoever's last name is on the group. So like when we say the Johnstone group, we're talking about Timothy Johnstone. Emailing them, their website, will have their email. Their email is also just through the whole email thing. You know how email works. But yeah, so emailing them, or if you have a grad student who is maybe your TA, who you've built a good relationship with, talking with them, they can talk with their PI, kind of like all kind of come together to work through this. So yeah, there's not like one necessary way, but yeah, if you don't know grad students in the lab, my recommendation would be to form a relationship with that professor, reach out to the professor.
Okay, and when reaching out, are you expected to have like a cover letter tailored to every lab that you're looking into? I know that you obviously probably just submit your CV to everyone. What about like your transcript? What kind of things are they looking for?
A lot of the times, it is on one of the websites when I was like reaching out to professors. I can't recall off the top of my head, but a useful thing is to mention classes that you've taken that possibly cover what they're working on. So like if you know that they're an inorganic lab, and if you've taken 151A, mention that, because those are the concepts that will be talked about in the lab or in the research. And then also going back to your previous question, different grad students are usually doing different projects. So if you already like know what project in mind that you want to pursue, maybe talking to that grad student specifically. Because when I was trying to reach out to Tim about it, because I did it sort of backwards, he was like, after I met with him, he was like, now is your time to talk to the grad students, but I already had a grad student in mind. So it really comes down to like who you think you'd work best with alongside whose research you also want to pursue.
That's okay. Are labs looking for more like longevity? Are they looking, or are they only looking for like upperclassmen who have taken a lot of the more focused chemistry, biology courses, that kind of thing?
Both. I think both, because like it's good sometimes if you're getting into like a synthetic lab, it's like they want you to have organic and they want you to like have gone through, you know, like the advanced organic classes, but you can totally access a research opportunity after taking like a couple of quarters of gen. Like it's 100% just like how much passion you have for it.
Yeah, I will say I joined my lab at the end of Chem 1A, so that was my chemistry experience. So in one sense, I got really lucky. I sort of had a trial by fire where I learned a lot of my chemistry in the lab. And I think, yeah, when I've seen grad students come through the lab, not grad students, undergrad students, yeah, there are two routes you can kind of like take. Either way, you can sell yourself, but if you're newer to the school, like you're a younger first year, second year student, longevity is huge because they take the time to train you, and then they know that there will be a return on that investment. But also, if you're an upperclassman, you have a lot more. You just have a lot more chemistry background, so that's something that you can bring to the table. So I would say either way, there's not a right time or there's not a wrong time to start to join a lab. But if you want to, start looking today.
I love getting freshmen a lot more than lab because just like Connor said, like there is a learning curve and it's a huge investment for somebody in the lab to train you. So the idea that like then you can like have 2 years and like a couple of summers like being dedicated, like those are the people who become like Connor. I mean, who publish papers and do theses are really the people who get in early and have. It takes time. Even the graduate students go 2-3 years before they publish something. So yeah, it's great to get involved early. But there's one other comment I wanted to make. Oh, I wanted to give you my perspective on the email that you should craft. as a professor. I think, yeah, like put in your transcript, you can attach a transcript, attach a resume, CV. I think the most important thing is to convey in a few sentences, why are you writing to that person? What is it about that lab that interests you? And relating it to something you've taken in classes that was brought up, like, hey, I took 151A and I found like main group chemistry super interesting. That's what your lab does. So like, I'm interested in your lab, right? Or,
Okay.
yeah.
So would you want like a cover letter that said like,
It doesn't need to be like a whole formal cover letter, but like a paragraph, like, dear Professor so-and-so, I'm a second year intended chemistry major. I became familiar with your lab from your website. I'm really interested in what you're doing because of this. And other things to add that I think are always good is that you're willing to volunteer, if you can, and willing to volunteer. That I would put, yeah, I'll leave it at that. And like that, if you could, that you understand, and they'll probably tell you that it takes like 10 to 15 hours. Or just say you're willing to volunteer. Yeah. Sorry, go ahead.
I'm an MCD bio major, but I'm interested in biochemistry research. Possibly getting into that. Is there an overlap of like departments and?
Oh yeah, yeah, for sure. Like all the research in the department, I would characterize as interdisciplinary, where there's either overlap between chemistry and biology. Like my own research, people who do what I do are often in biology departments, or like Kim Johnstone interface of biology and chemistry. Scott Oliver, interface of materials physics and chemistry. So yeah, and by the way, everything that we've said today could apply to an MCD major as well. So and I've had MCD majors in my lab. The chemistry students go over to biology to do research. Biology students come over to chemistry. Not like because you're an MCD research, you can only find MCD major. You can only find a faculty over there. By all means, you should be writing to everybody. Yeah.
Sorry.
That's okay. You're good question.
Is there a best time that labs are usually looking for people? I know that sometimes it's just kind of when people rotate in and out. Is it like summer because then there's more freedom from professors time-wise?
Probably the best time is like when there's turnover, like when seniors graduate. So like in the spring, but there really is no, I mean, just stuff comes up. You know, I wanted to say this too. The main thing that determines when I can say yes to somebody or interview somebody and when I just have to immediately say, no, sorry, I don't have any room, is availability of somebody in the lab to train that person, and that they're at a point in their project, like Sarah's PhD students at a point in their project where they can take on an undergraduate student, train them, and that they have part of their project is suitable for somebody to be working with. And so just whenever that happens, and whenever an undergrad emails me like that week, then I'm like, yeah, turns out we're looking for somebody to interview. So often the no's that you get or lack of response you can get is gonna have nothing to do with like you, but just is there availability. And that also, by the way, is why I agree it's such a good idea to go in, get in through the grad students, because if a grad student in my lab came to me and said, hey, I met this person in my class and they seem great and I'm willing to train them, I'm like, do it. So, because for me, it's always like just availability of grad student time and willingness.
Okay, thank you.
Yeah.
Would you recommend like reaching out to graduate students who aren't necessarily your TA? Like, would that be okay?
Absolutely. People also like love talking about their research. Like they spend all their time, like we spend 60 hours a week doing it. So people like want to be like, oh, you're interested in my project? And they will be so.
Okay.
Yeah.
If you're reaching out to a professor and you're really like in their lab, I understand like you said, there's times when there's candidates that are students. So I told her a pre-credit course last year about research construction, and one of the speakers was saying like if there wasn't a response, emailing over and over and over, did you advise that, or should we just assume that they got it and they'll get back to you when?
I would definitely send in one or two. I mean, it's a fine line between being persistent and being annoying.
Yeah.
But I would err on the side of being persistent for sure. Definitely don't send one email and then not follow up, because so many faculty, and it varies just people's nature. Some respond right away and are good about keeping it with email. Others, more like a sort of advisor trying to chat to faculty. There's a lot of faculty who just like are really bad with and they like need to see it in their inbox at the top again. So if like a week goes by and you don't hear anything, I would definitely send a follow-up, maybe two. If you want to be bold and go bang on their door, do that. That's depending on the person, sometimes rubs them the wrong way, but I don't know. I mean, the alternative is that you don't get an answer anyway, so might as well slightly annoying. Yeah, I don't know. What do you guys think about that?
I will say, working with Scott, sometimes emailing more than once can be helpful, even as a member in his lab, but like, a lot of it is like, before we go into the group meeting, he just got an email recently about someone saying something, right? Sometimes he'll miss things, sometimes he'll forget. He's a person. Emailing more than once just helps your name come up. And then if grad students are like, hey, I was hoping to take on an undergrad, or like I'm at a point where I'd like to take on an undergrad, your names come up a couple of times, suddenly you're at the top of the list. So I don't think that's a bad idea. I would also say though that even if you have your heart super set on one lab, there is still a huge benefit to joining like an adjacent lab. At this point, like at an undergraduate level, the only way you can go is up. You'll learn a bunch of techniques, you'll gain a bunch of experience. And then maybe after a while, hey, now I have this experience, you can try to switch labs and start working on that project as well, which is something I'm currently doing. So I think it was a lot easier for me to transition after having been in a lab to then say, I'd like to come and work in this lab and do this project.
Yeah, the way what I always say is like, do the research that I was talking about, visit websites, find the ones that really stand out, that just grab your attention right away. Start by emailing them, but keep looking. And even if it's not like immediately related to what you think you want to do, at some point start emailing them too, because you guys are also young and this is also new, that like you're going to find stuff that you didn't even know you were interested in. And as been said, just getting any experience is a foot in the door and you'll learn a lot from it. Yeah.
Will a professor be deterred if maybe you're looking at their lab, you've taken their class, and you didn't do exceedingly well in it?
No, probably. I don't know. Some would.
Would you be deterred?
I personally? No, especially if it's like an outlier. I mean, I would say that I am hesitant to take students who have low grades. For me, even more than I don't think they can do the research, because I think anybody can do the research if they're dedicated to it. It's like grades are so important for what you want to do next. It's like I worry that that person doesn't have the time to do the research that they should be focusing more on grades. So low grades, I would advise you to think about that, figure out why you're getting low grades and fix that. But like, you know, the students getting good grades, but like they tanked my class, I wouldn't care. Last burning question, we can stick around, but I do want to let people go who have other things to do. But again, thank you all for coming. It's amazing to see. Oh shoot, I forgot. There's one more thing I really want to say. Some of you may or may not be aware, but there's a new trend on campus in biology, chemistry, some of the other departments to do what are called CURE classes, coursework, undergraduate research experience. So these are upper division lab classes that are not like your typical lab class where there's like a manual and the experiment's been done 1,000 times, like you all did in Chem 1M. But that this lab class is actually doing a real research project. And so I actually started one in chemistry. I'm doing a biochemistry cure lab. It's called Chemistry 160 Biochemistry Research Lab. There's 2 currently MCD. There's probably 2 more, so there's going to be like 5 next year. And this is just a class that you sign up for. You just register for it. There's usually a short application you have to fill out. But that, short of joining a lab like we've been talking about all day, I think the next best thing, in some ways I would argue even like a better experience, is to do one of these cure labs where you'll be doing a real research project, group of like 10 to 15 of your peers, one professor mentoring you and teaching you about the research. And I'm happy to talk about more what I'm doing in mine or what some of the other ones are doing. Right now there's 3, next year there's going to be 5. So look through the course catalogs or ask your advisors about them. That's also a really amazing opportunity to get research experience. Okay, thank you. I'll stick around.